When you turn on your kitchen sink to get a glass of water, you probably don't think about how it got there. That simple flow of water is the final step of a journey through a massive, hidden network of underground tunnels. To move all that water across a city, engineers rely on something called a ductile iron pipe. It's a rugged, heavy-duty metal tube that can sit underground for decades without failing. Moving these enormous structures into place is a challenge that stretches back generations. Looking at this historical photo of a city street trench, you see crews wrestling with the immense scale of these installations for over a century. Even today, with modern equipment, the most difficult part of the job isn't actually digging the hole in the ground. It's figuring out how to safely lift, position, and connect thousands of pounds of raw, unforgiving metal. Which brings up an interesting question. If a construction crew needs to lower just a single, standard 20-foot section of pipe into the ground, how much weight are they really dealing with? Here is a standard 12-inch diameter pipe. Its weight is driven by wall thickness, which withstands extreme internal pressure and traffic above. This iron shell weighs 43 pounds per foot. Expanded to a 20-foot segment, the empty weight climbs to nearly 900 pounds. As the diameter gets wider, the iron volume needed to maintain that protective wall grows incredibly fast, pushing the weight into the thousands of pounds. High-pressure water systems simply cannot rely on thin, lightweight materials. To guarantee a pipe won't burst under the street, it requires a genuinely heavy foundation. But that 900-pound shell is only part of the story. To keep your drinking water perfectly clean, it cannot flow directly against bare iron. Manufacturers spin a thin layer of cement inside the pipe to protect the metal from rusting. Spreading this lining across 20 feet adds extra pounds to the total weight that logistics teams must account for. When the pipeline is buried and turned on, the heaviest component isn't metal or cement, it's water. Completely full, rushing water adds over 50 pounds per foot. The fluid weighs more than the iron pipe holding it. A municipal pipeline is never an empty tube. When you add up the heavy iron shell, the cement lining, and the rushing water, you get a massive, multi-layered structure. Getting out of the math and into the dirt trench, you can see the reality of this weight. Looking at this photo of crews grinding and welding, it becomes clear how cramped these spaces are when joining such heavy objects. Because a single segment of pipe easily weighs well over 1,000 pounds, site managers cannot afford to guess. Rough estimates lead to mistakes, and in this line of work, mistakes are dangerous. Instead, engineers use precise digital calculators and standard manufacturer charts to sum up the exact weight of the diameter, the metal thickness, and the inner linings before a single shovel hits the dirt. Knowing that precise number is what tells a crew exactly what equipment to bring. It is the difference between safely using a standard backhoe to lower a piece into the trench or needing to bring in a heavy industrial crane. It also controls the transportation. Because highways have very strict weight limits, understanding the math is the only way a dispatcher knows exactly how many pipes can safely fit onto a single flatbed delivery truck. Most importantly, it keeps the worker safe. Calculating the exact weight load ensures that lifting cables don't snap, equipment doesn't tip, and the sides of the trench don't collapse on top of the crew. Mastering the hidden math of pipe weight takes the guesswork out of building our infrastructure. It allows these crews to safely manage millions of pounds of iron, doing the heavy lifting so that your tap never runs dry.